Okay, so the first condition is that an has to be greater than or equal to 0, and the bn has to be like n minus 1, which is like the smaller equation. So like an has to be like less than or equal to bn in order for it to be convergent. But if that's not the case, and it's the other way around, where an is greater than or equal to bn, then it's divergent. Because and the reason an when an is less than or equal to bn, the reason that converges is because if the bigger equation converges, then the smaller one will too. But if for the other way around, it's like if the bigger equation diverges, then obviously the smaller one will too.
Okay.
And then we have the integral test, which is like what we have like 3 criteria it needs to satisfy, which is it has to be continuous, which means like the function has to be like it has to go on for all the values of n that you input, and then decreasing, which is the an has to be like whatever the next part of the series is, like it has to be keep decreasing over time. So like a plus 1 has to be less than an, and an has to be positive. Like you can't use the integral test if it's a negative, if the original equation is negative. And then so if an so like and then there's just another condition that goes with this, and that's if the limit function is like an is converging, then so will the function. And then same thing with diverging. Like if an diverges, then f of x will diverge. And then the p-series test, this is very simple. All you have to do is see if the power of n, which is p here, the power of like n power p, if you look at p and it's greater than 0, then it qualifies for the p-series test. And if p is greater than 1, then it's converging. But if p is less than or equal to 1, then it's diverging. And yeah. And then we have the alternating series test, which basically is like the condition you need to use this test is to have the series alternating, which if you put -1 to the power of n, that will like automatically make the series alternating. Like basically has to change from being positive to negative with every like n value. And one of the ways to check this, like one of the steps, is that 0 has to be greater than an plus 1, which is basically the second part of the series, and then has to also be greater than equal to an. And the very important thing here is that both have to be an absolute value in order for it to like, because you can't do it with like a negative value. They have to both be positive, and like your given equation has to be bigger than like the next equation, basically the next part of the series. And so the other condition is like if the limit is equal to 0, then it's convergent. But if it doesn't, then it's divergent. And then we have the absolute convergent test, which is basically
Scroll up more.
Yeah. So the absolute conversion test is basically just like just putting like the given equation, or given equation an into absolute value, and then if that's convergent, then the an is all like just the value itself without the absolute value will be convergent, not value, the equation. And then we have the ratio test, which is basically taking the second part of the series and then the given part of the series, in dividing the second to the first and putting it all in an absolute value, and then and then you just solve for the limit for that, and then whatever value you get, if the value is greater than 1, then it's converging, and then if it's less than 1, then it's diverging. But if it's equal to 1, then it's inconclusive. That means it's like this test doesn't tell you anything, if you get that. But yeah.